Writing code from the description of a problem requires lots of time and overthought. That's why, before you attempt to write the code from the description of the problem, remember that problem can be divided into logical steps to reach a solution. And to solve any problem, same type of operations and methods are used. Therefore, in this lecture, we will understand why a problem description needs to be converted to definite steps to reach a solution. In computer science, the logical steps to solve a problem is named as the algorithm. In other words, it is a step-by-step plan to solve a problem. In computers, a logical sequence of steps is in the form of code. Since writing code from the description of the problem is difficult and requires overthought, pseudocode can be used to express solution in common language for solving a problem in any computer language. Almost all of the programming languages follow similar patterns, methods, and operations for writing code. In all of the programming, following types of statements are written in pseudocode to solve a problem. Understanding these statements could help you express any problem description into pseudocode, and then you would just need knowledge of a specific programming language to write code. First thing in problem description to identify are the variables. Variables are the names that hold a specific type of value. Assignments are statements that assign or store values to results of some operation in variables. All the computer programs work with input-output operations, so there must be some statement in pseudocode to express input-output operations. Main logical steps in any algorithm are selection and repetition. Selection statements allow us to make a choice between performing an action or skipping it, based on some condition. And the fifth and last element in pseudocode or any computer program is repetition. Repetitions allow us to repeat an instruction in pseudocode or computer program to repeat a certain number of times based on some condition. Variables in algorithms, as discussed previously, represent a specific content like result of calculation, like sum, total, average. They also represent names of places or can be used to keep track of the count for the statements that will repeat, also known as counter variable. In computers, a variable refers to the location in memory where a specific kind of data is stored. Different programming languages have different syntax for creating and using variables in code. For example, in Java, a variable is created with data type, variable name, and a semicolon at the end. Variables are created to hold the values or results of operations. Assignment statements in algorithm are used for assigning or storing values to variables. For example, in previous slide, we created a variable sum. In pseudocode, we can simply write sum is set to 0, which means sum is assigned a value 0, or you can use a backward arrow to assign a value to a variable. In programming languages, assignment statements contain variable on left side to which value is assigned, then comes equal sign, and then the value you want to assign. For example, in first statement, sum is declared and assigned value 0. In second statement, num is added to the value of sum and result is assigned back to the variable sum. In computer programs, input is provided through a keyboard or some input device and output is returned to some display device. In computer programs, we have to write specific statements to get the values from user and show output. In pseudocode, words used for input statements are get and read, and for output statements, write, display, and print are commonly used. Programming languages use different types of syntax. In Java, we can use a scanner class to get a specific type of input, but output is displayed using the method system.out.println method. There are some programming languages that use concise statements for these types of operations like Python and JavaScript. So you will not have any difficulty in converting your pseudocode to computer program in languages like these. In real life, we find repetition everywhere. number of days repeat in week, weeks in month, and months in year. We regularly do some action repeatedly. In algorithms, repetition constructs allow us to repeat a specific instruction. In programming terms, repetition structure are called loops, that is, for loop and while loop. For repetition, counter variable is used in loops to control the repetition of certain instruction. For this purpose, counter variable is initialized with a value, tested against a condition, and incremented a certain or limited number of times based on some condition. In the following pseudocode algorithm, we have created a variable limit, set its value to number of values we want to sum. Then in loop we have the condition that while counter is less than limit, get number as input, set the sum to sum plus number, and increment the counter. Since at the beginning of program counter is considered to be 0, each time instruction is repeated, counter variable's value increases by 1. When counter variable reaches value of limit, repetition stops. In real life, we come across many situations where we have to make a choice between different things or select from different alternatives based on certain situations. In computers, selection construct allows a choice between two actions. In programming terms, if-else and else-if statements are used to select the instructions that need to be executed based on the condition. Following pseudocode prints or selects first statement to execute if age is less than 18, else it prints the second statement. Thanks for watching this video. If you liked it, subscribe the channel for support.